and welcome. We are going to talk about a very important feature in the Linux command line, which is called pipes. Pipes are the ability of one program to emit its output as the input for another program. Or if you look at it another way, it's the ability of one program to consume the output from a previous program. Pipes are very well embedded in the Unix philosophy, and they are very powerful tools once we learn how to use them. So let's have a look at how we can use pipes and what we can do with them. I have here a log from my application. The log file, as we can see, has a timestamp and then an information warning or error, and then we have some kind of a message. Sometimes it's about how much the operation took place, and otherwise it just errors random messages. And we would like to know what to do with it. So when we look at the command line and the things we can look at the application, we can just use the program cat. Cat can take one or more files and just prints out what's inside the file to the output. But this is not really helpful. There are many lines in the file, and everything happened too quick. So the first question we can ask is, how many log lines do we have in this file? And for that, we're going to use a pipe, which is done with a vertical bar sign. It's different from various keyboards to various keyboards, but it's usually shift, and on my keyboard it's a backslash, but you can find it in your keyboard. And then I'm going to pipe it to something called WC. WC is short for word count, and when I say WC-L, it says count only how many lines you have seen. So when I do that, I see that I almost have 20,000 worth of lines in my log file, right? Let's see from I can see them. So one program I can use is called head, and head will give me the beginning of the file, and I see that the start is from March 11, and the same as head, we also have something called tail, and tail will give me the last lines of the file. And here I see that I have it until March 18. Okay, so I have a week worth of logging data, and I can quickly look using pipes at the beginning of the file and see how many lines of files we have. And then let's say that I want to see how many errors I have in the file. Okay, for that again we're going to use another program, and this is very common in Unix. You use a lot of small programs, each one does one thing, and it consumes some input and produce some outputs, and you connect them together with pipes to get the things that you want to. And grep is something which will emit only lines that are matching whatever you give it. So if I'll do a grep of error, and let's pipe it just to head, I'll see that now I'm seeing only error lines. I don't see the debug and the info. And again here, I can do the WC-L and see that I have 3,287 error lines. If you remember, when we looked at the whole file, we saw that we have almost 20,000. So what is the percentage of the error lines from the total lines? We can use another program and say 3,287 divided by 19988, and let's multiply it by 100 to get percents. And I'm going to pipe it to something called BC. BC is a calculator, and when I do BC-L, it gets the input from the command line and emits the result. So about 16.4% of my log lines are errors, which is really high number, and this is just dummy data that I generated. In your application you should be way less than 1% of error logs. But again, using the command line tools and piping one thing to another, we can find out easily the question, to answer the question, what is the percentage of log lines that we have? Okay, now let's try something which is a little bit more complex. It will involve a list of files, but the question I want to answer is, what is the average time of a database operation? If we look at the data, we see that we have information messages, the one that starts with info, and there is also the component. There's a database, a queue, and a web server. And when we have informational databases, we see that we have operation took 823 milliseconds, and for the web, the operation took 641 milliseconds, etc., etc. So we want to know what is the average amount of, what is the average time that the database operation took. Okay, so let's start and think in pipes. So the first thing we want to see only the lines that interest us. They are the informational from the database. So we are going to grab info database, and again I'll just pipe it to head. Sorry, I forgot to do a grep here. You see, now I see only the lines that are there. Now I want to see only, I'm interested only in part of the line. I'm interested only in the numbers, these numbers, the 823, 787, 220, etc., etc. And for that, I'm going to use the grep that we saw earlier. Grep has an option of emitting just the part of the line that matches what we were looking. Grep is actually using something called regular expressions, which is a big subject. We're not going to cover it. But in our case, we're going to say we're looking for some numbers. So it's something between 0 and 9. And then the word millisecond. Okay, now we see that we get only the last part of the line. Now we're interested only in the numbers. So we want to cut this one even further, and this time we're going to use something called cut. And cut is another command line utility. You say, what is the delimiter? And you said delimiter is space, and I'm interested in the first field of the line. And again, we'll pipe it through head, and we see that we get only a list of numbers. So far, we managed to just sample our data. So we filter out the lines that we're interested, and then from the lines we take just the information that is interesting to us. Now we have a long list of numbers, and we would like to know how can we calculate the average. And for that we're going to use another program. This one is called awk. And awk is a small language by itself, and we're not going to introduce the whole of awk, but just going to see how we write a small program in awk. And awk and also another program called SED, S-E-D, are two very useful programs. You can do a lot of stuff with them once you get the hang of them. So now, because the line is getting longer, I'm going to use a backslash, and I'll write the awk part at the rest of the line. And I'm going to do awk, and then I'm going to give it a program to do. So I'm going to say increment the number, increment n, with the first argument that you got, which is the numbers. And then at the end, you print the number divided by nr. nr is the number of records, it's the number of things that awk saw. Okay? And when we do that, we actually sum up the numbers, and then we divide them by how many numbers there were. And when we run that, we see that the average number of a database, the average time for database operation is about half a second, right? It's 502 milliseconds. So this is it. These are pipes in the Linux command line, and as I said, these are very, very powerful. Once you get the hang of pipes and the fact that you have a lot of small utilities that you just pipe data from one to another, you have a lot of flexible ways to create exactly what you want without needing to write your own big programs or a lot of other things. And this is very well embedded in the Unix philosophy, and I highly recommend you practice that, you think about problems and try to solve them with small applications. And we saw some of the major ones that people use. We use grep, we used cut, we used awk, and as I said, there's also, and we used grep, and of course there is also SED, S-E-D, and we talked about BC, which is a kind of a calculator. There are many other ones in the Linux world, and once you get familiar with them, you get comfortable, you started to see you can work with them, and they're pretty fast. because they're small and usually written in high efficient C, you can process big amount of data fairly fast with only just these utilities, so you don't have to write a lot of big and complex programs to do whatever you want.